All right, everyone. Today we're going to go over some applications of quadratic functions, specifically projectile motion. Projectile motion is typically something you would talk about in a physics class, but we're going to talk about it at the level of Algebra 1. This course is designed for students who have an Algebra 1 background, so we're only going to do things that are capable in that aspect. So let's take a look at a scenario, right? Projectile motion, anything that takes a parabolic shape, just like a quadratic function, right? So as you can see, this baseball thrower, he threw the baseball, right? And it's going up at a certain rate and it's coming back down. So there's a couple things you want to take a look at here, right? As he throws the ball, just for a little bit of physics background, there's actually two forces going on this ball, right? So if I were to take a look at the ball at this point, there is what we call a horizontal and a vertical force, or horizontal and vertical acceleration. Okay, so the horizontal is going to take it from left to right, and then the vertical is going to start up going up. But as you notice, the vertical acceleration on this ball is actually going to decrease over time. So notice that line's not as big, right? But the horizontal aspect is going to keep on going. Okay, so what's going to happen is at the top, that vertical acceleration or that vertical velocity is actually going to become zero, but the horizontal is going to keep on going. And as it keeps going until it hits the ground, there's going to slowly start becoming a negative force on that ball. And for those of you who probably took a guess, that is because of gravity. Okay, so we need to account for gravity in this situation. So let's take a look at an equation that we can use for this. So what we're going to do is we're going to talk about this as a function. And we're only going to talk about this in terms of height right now. We don't know how to deal with this for both horizontal and vertical without dealing with some trigonometry or some other things that you learn in more advanced algebra or physics. So we're only going to look at this from vertical height only. Okay, so if I were to take a look at this, there's a couple things that can affect that, right? I have to take a look at gravity, which I'm going to label all these variables in a second. I have to take a look at the velocity or the speed. And I have to worry about where is this object starting from? Is it starting from the ground or is it starting from a little higher up? So let's label all these variables, right? So h of t is just the height of the object based on time, right? It's a function. Height is a function of time in this case. And in this case, the height can be given as either feet or in meters, right? We're going to look at a situation that deals with both of these, okay? We also have to worry about gravity, which we'll come back to in a second. V stands for the initial upward velocity. We're only going to care about the upward velocity right now. Once again, that's only because we're dealing with vertical, okay? And velocity is either going to be feet per second or meters per second if we're dealing with meters. All right. And then the last thing, variable there we don't know, is the S, which is we're going to call that the initial height. Most people would use an H for initial height. We can't use H because we're using that for the actual height. Okay. So we're just going to call this the initial height of the object. And that's going to be given in either feet or meters, whatever we are dealing with in this case. Okay. So let's come back to graph. Oh, we also have time, which is always going to be in seconds. All right. And then let's go back to gravity now. So gravity is going to depend on this. So what we have is this is called a gravitational constant. And remember, a constant is just a number that doesn't change. And the reason why it doesn't change is because gravity is typically the same everywhere in the world, right? So we're going to make an assumption, right, that if we were dealing with feet, we're going to say negative 16 feet per second. That's going to be my gravitational force here. Okay. And then this one's going to be negative 4.9 meters per second. And these are just basically half of the force of gravity based on Earth, right? So these are based on half of the force of gravity. Okay, that's what those are based on. So let's take a look at a couple of examples moving forward. All right. So we're going to take a look at a soccer ball being kicked upwards from the ground with an initial velocity of 3.6 meters per second. After how many seconds will the ball return to the ground? So there's a couple things we want to take a look at here, right? In this first example, we realize it's starting at the ground. So S is going to be 0, okay? Initial vertical velocity of 3.6 meters per second. So that means V is 3.6. And we need to figure out that. And we're dealing with meters. Okay, so since we're dealing with meters, G is going to be the negative 4.9 here. Okay, meters per second. So let's plug all this into the function, right? So we have a function based on time. H is going to be negative 4.9. That's the gravity. Okay, t squared. And you can notice that this is the reason why this is a quadratic application is because the t squared, right? This looks like the standard form of a quadratic function. The velocity is 3.6 t. And once again, these are all just based on the formula that I gave you up top, right? We don't know what the time is yet. That's what we're trying to find. And the last thing is 0. But we also know that we don't really need 0 in this case. So I'm just going to cross that off because that's just going to be 0. So a couple ways you can solve this. I'm going to do all the problems today using the quadratic formula, right? And the quadratic formula basically finds your dependent variable using all the coefficients, right? And just as a reminder, it's negative b plus or minus the square root of b squared minus 4ac all over 2a. And in this case, a is going to be negative 4.9, b is going to be 3.6, and c is 0. All right, and now that we identified those, we can plug those right into this formula. So let's take a look. So we have t, and then we have negative b, so that's negative 3.6 plus or minus the square root of 3.6 squared minus 4 times a, which is negative 4.9, times c, which is just 0. So that's going to end out nice in a second. I'll show you how. And then we have 2 times negative 4.9. All right, so inside of that square root symbol, if you take a look, we have 0 times all this, so that's just going to end up being 0. All right, so what are we left with? We're left with negative 3.6 plus or minus the square root of 3.6 squared. And the cool thing about that is those are just going to cancel. And then we have 2 times 4.9 is negative 9.8. So we're left just with like negative 3.6 over negative 9.8 plus or minus 3.6 on top. Forgot about that. Sorry. And that leaves us with two different options, right? Remember, the plus or minus just means we do the two different things. So we have t is equal to 0 over 9.8 if we add them together, or negative 9.8. And that just gives us 0. Or we have t, if you subtract them, you get negative 7.2 over negative 9.8, which is about 0.73 seconds. So what does that mean? That means that the ball will return to the ground, right? This one we can just ignore because we already know it started to the ground when t is 0, right? But in about 0.73 seconds, so about 7/10 of a second, you would be back on the ground. Okay, let's look at another example. An underhand volleyball serve is performed 4 feet off the ground with an initial upward velocity of 30 feet per second. When will the ball be located 16 feet above the ground? So let's take a look at this. We have 4 feet off the ground being our initial height. So that would be s equals 4. Initial upward velocity of 30. So that is v equals 30 feet per second. And we want to know when the height is going to be 16 feet above the ground. So we want to know what value of t is going to make that 16. Okay, so this is one additional piece of information. Okay, so if I go to plug this in, I have, instead of h of t, I want my new height at the end to be 16. So it's not what I'm finding. I'm already told what it is, and I have to find the value of t. Okay, so this is very similar. So we have negative 16 t squared plus 30t minus, oops, my apologies, plus 4. Okay, here's why I said minus just a second ago, right? I need to set this equal to 0 first, right? So in theory, what we did is after we have this function, we want to know when the height is 0, when it's back on the ground, right? So I have to remake this 0. So I'm just going to subtract 16 from both sides. And we have 0 equals negative 16 t squared plus 30. And now that's going to be negative 12. So now that, notice, if some people might just start doing it right away using the 4, that is not correct, right? You have to get that negative 12 first. Now I'm going to plug those in, right? So A is negative 16, B is 30, C is negative 12. Well, let's go ahead and plug these in. So T is equal to, we have negative 30 plus or minus the square root of 30 squared. Right, 30 is just the velocity. All right. And we have minus 4 times negative 16. And then we also have negative 12 as our C. All that over 2 times A, which is negative 16. And we can just start solving that out. So we're left with T equals negative 30 plus or minus 30 squared is 900. And then if I do negative 4 times negative 16 times negative 12, I'm left with negative 768. And then 2 times negative 16 is negative 32. I can simplify that a little bit. I get negative 30 plus or minus the square root of 900 minus 76 is 132, all over negative 32. And I just have to start actually doing this, which, believe it or not, the best way to just do is to just do this in your calculator. So what's going to happen is you're going to have t is negative 30 plus square root of 132 over negative 32. And t equals negative 30 minus square root of 132 over negative 32. And those two values are going to be, if you add it, you'll end up getting 0.58, and the other one is going to be 1.29. And that makes sense because 16 feet is higher than 4 feet above the ground. So what's going to actually happen is if I were to draw this, right, if I were to start at 4 feet, I'm going to come up and it's going to go back down. It's going to be at 16 feet at 2 different times. Okay, so one of those times would be at 0.58 seconds, and the other one would be at 1.29 seconds. All right. And one last question. Basically, what we're going to do here is we have to find the maximum height a ball would reach. If I was a football player, I punted it when it was 2 feet above the ground. So let's take a look at this. So S would be 2. Upwards initial velocity is 75. And once again, we're dealing with feet in this case. So gravity is going to be negative 16. That's the reason why it was negative 16 in the last problem as well. So let's plug all this into a function, because that's all the information we can get from there. So we have negative 16 was where g belongs at the beginning, with t squared plus 75 t plus 2. So that would be our formula we're starting with. But this is not one of those problems where we're going to have to find out how long until it gets to a certain point, right? I want to find out what is the maximum height. And just as a reminder, I've talked about this before, right? If you look at the quadratic formula, right? If I look at just the top beginning part, so that's negative b and the denominator 2a. That's kind of like our center, right? When we add or subtract that square root or the radical expression, all we're doing is we're going out a little bit more, either up or down, depending on the direction of the parabola. So all we're going to have to do there is just use that top part, and this is actually the time that you'll have your maximum height or minimum height, but in this case, it could be maximum. So that's our maximum height time. Okay, and that's used using negative b over 2a. So let's actually do that. So that's going to be negative 75 over 2 times negative 16. So negative 75 over negative 32 is about 2.34 seconds if you do that in your calculator. And we're not done yet. That just tells us the time that it's going to reach its maximum height, which kind of makes sense, right? It's a little farther along the path, right, of the ball being up in the air. So in order to find the height, I'm given a time, right? Once again, this is just a value of t, right? So I can just plug that in to my function. So what does that mean? If I want the height at 2.34 seconds, right, then all I have to do is do that, okay? So the height at 2.34 seconds is I'm just going to plug in 2.34 every time I see t. So notice that's where t was before, 2.34 squared plus 75, and then there was another t, so 2.34 plus 2. And let's do all that math out real quick. So this is negative 16. Order of operations says to square it first. So that's about 5.4756. I'll round it a little bit or expand it a little bit. And then we have 75 times that is about 175.5. And then plus the 2 on the end again, right? I can multiply this next step right here. And then we have about negative 87.61. And then if I add these two together over here, I get 177.5. And at the very end, the height at 2.34 seconds is about 89.9 feet. And if you were ever unsure of what these answers were and you don't like doing all this math, right, you could always plug the function that we get into a graphing calculator, except you would have to use x instead of t, right? So if you were to put this in Desmos or a TI-84 calculator, right, you would clearly see that at the top point you would be at about 89.9 feet, give or take a couple decimal points. Okay, so that's going to be it for today. I know that was a lot. Please make sure if you have any questions, comment in the comments below, contact your tutor or your teacher. And until next time, please make sure you like, comment, and subscribe, and we'll see you next time.